In the previous little lesson, we had a look at complementary angles and the symmetry properties therein. And we came up with 6 different symmetry properties. We came up with this pair here, we came up with this pair here, and we came up with this pair here. In each instance, when we took an angle away from one of the y-axis, lines, I suppose, we ended up seeing a relationship where sine got converted to cosine and cosine got converted to sine with a plus or a minus next to it depending on what was happening with the quadrant. So we were able to simplify our expressions by using that symmetry property. And in today's lesson, we are going to look at that as an example. Now, you could memorize all 6 symmetry properties and then just apply them directly to each problem. But I suggest that might be fraught with difficulty in remembering which one belongs to which quadrant. So the way I'm going to do this one is take you through these 5 examples, and we are going to sort of construct a little bit of meaning out of them each time in order to make sure that we're not making mistakes. So here we go. The example is that given sine of theta equals negative root 3 on 2. And before I go any further here, as soon as you see this negative in front of the root 3 on 2, that should tell you which quadrant that theta is in. Slightly at least, anyway. It's got to be in quadrant 3 or quadrant 4. According to our cast diagram, quadrant 3 and quadrant 4 is where sine has a negative value. And yes, sure enough, when I look at the domain itself, I can see that theta is between 3 pi on 2 and 2 pi. So it is in the 4th quadrant. And we've got 5 things we need to find. All of them either adding or taking theta away from 3 pi on 2. So it's definitely about taking it away from a y-axis. My steps are as follows. First of all, find cos theta. So we're going to draw a triangle, and we're going to work out what the cos of theta is, assuming that theta is acute, sort of. It's really we're looking at theta hat, and we're figuring it out from a theta hat perspective. But anyway, you can also use Pythagorean identity as well. Sine squared plus cos squared equals 1. So if I had, say, for example, sine theta equals negative 0.2, I'd probably use the Pythagorean identity. Because I've got it as a fraction here, it's just going to be easy enough to use a triangle, and that's my preferred way of doing it. So let me just change colour so it stands out a little bit. So we've got the triangle here, a right angle triangle with theta over here. And looking at it, it says negative root 3 on 2, but we're just going to ignore the negative for a second. And I'm going to put root 3 on one side of the triangle. That's opposite theta. And then 2 is going to be placed on the hypotenuse because sine is opposite over hypotenuse. And now I'm going to use Pythagoras' theorem to work out the missing side. And the missing side is going to be hypotenuse squared minus the other side squared, and then square root the lot for the missing side. And it gives me the square root of 4 minus 3, which is 1. And we're going to have it as positive, and so I can fill in the missing side length of 1. Okay, so that's all good. That's all done. We can therefore conclude that cos of theta is equal to adjacent over hypotenuse, which is 1 over 2. So I can write 1 over 2. And then we return back to what theta actually is, because we don't know whether cos of theta is positive or negative. So we go here and we say, wait a minute, where's theta? Theta is between 3 pi on 2 and 2 pi. It's a 4th quadrant angle where cosine is positive, and so cosine theta is equal to a half, not negative a half. Okay, for the rest of it, what we do basically is once having worked out cos of theta, we are then going to kind of treat theta as acute for the purposes of drawing a diagram, and then we're going to follow our noses from there. Trust me, it's not too hard, with a bit of practice at least anyway. So we've got sine of 3 pi on 2 plus theta. So what we're going to do is, if I do the most quickest of diagrams, I'll head back to black so it stands out a bit more. The quickest of diagrams, treating theta as if it were acute, I would be saying that 3 pi on 2 is where we start. So we're starting from here, and then we're going a plus theta, so it's an extra bit of theta here. So we can see that we've got a 4th quadrant angle here. So then I take sine of 3 pi on 2 plus theta and go straight into making it cos of theta. And then I just need to work out whether it's positive or negative. So in this quadrant here, only cosine is positive. However, we're not talking about this cosine. We're actually talking about, well, or angle. We're talking about this expression here. So sine is negative in this quadrant. And so we conclude that sine of 3 pi on 2 plus theta is equal to minus cosine of theta. Now, cosine of theta is equal to a half. And that means that we have sine of 3 pi on 2 plus theta equaling negative a half. And we're done. And just to show you that it does work, because theta isn't actually acute, if I very, very quickly, starting from 3 pi on 2, add theta as add theta as I should be, which is something which is a fourth quadrant angle, then I would be adding this much, that's pi on 2, and then this much, and that's pi, sorry, and then this much, which is 3 pi on 2, and then the rest of it. So all of this would be actually what theta is. And have a look here. We are actually ending up in quadrant 3. And in quadrant 3, using our cast diagram, CAST, only tan is positive here. So sine of 3 pi on 2 plus theta is equal to negative a half. It keeps the correct positive or negative because it actually ends up being in the appropriate plus or minus quadrant anyway. So I just wanted to point that out, that although we're treating theta like it's acute, it does actually work out. It's a bit mathematical, but it does work out. So this one here, cos of 3 pi on 2 plus theta. Again, we're starting from a right angle, so we're going to do a straight conversion into sine theta like so. Quickly drawing my diagram. It's getting a bit repetitive, I know. It shows us that 3 pi on 2 plus theta would look a bit like this, where cosine is positive. And therefore, I'm going to treat this cosine conversion as a positive one, so just sine theta. Now I'm going to go back and put in the value that I'm given for sine of theta, and I end up with negative root 3 on 2, and that is the answer. Now, again, you might go, wait a minute, cosine is positive in the fourth quadrant. Didn't we just work out the cosine? Why is it negative root 3 on 2? How has that worked out? Well, again, I take you back to the point that theta is not actually acute. It's actually between 3 pi on 2 and 2 pi, which means if I add that to 3 pi on 2, I'd be going around here and I would be in this quadrant, which, yes, cosine is negative in that quadrant, and that's why the final answer is negative here as well. Couple more examples and we are GTG. This time we've got sine of 3 pi on 2 minus theta. Again, we have an angle added, or in this case taken away from the y-axis, and so we are going to convert it into a cosine of theta. If I draw my diagram really quickly and treat theta as if it were acute, I would have that kind of arrangement. And again, this is CAST, tan is negative, and that means that our result here is going to be negative as well. So sine 3 pi on 2 minus theta equals negative cosine of theta. Now, cosine of theta, if you remember, we worked out is exactly equal to 1/2. And so we simply replace cosine of theta with 1/2 and we are done. It is equal to negative a half. Number 18, cosine of 3 pi on 2 minus theta. Same process again. We're taking it away from a y-axis, and so we go straight for a conversion from cosine to sine and leave it as theta. Drawing a very quick diagram, treating theta as acute, we can see it's in that third quadrant where cosine is also negative, and so we make our conversion negative as well, negative sine theta. Watch what happens as I go through though. Sine theta, if you remember, is negative root 3 on 2. And so when I substitute it in, I'll keep my brackets so we can see it really clearly. We've got sine of theta is negative root 3 on 2. We've got a negative of a negative, which means the actual answer is positive root 3 on 2. Again, it might not look like it, but if you do the rotations around, you will find that in fact the cosine of 3 pi on 2 minus theta, 3 pi on 2 minus theta will end up being in a quadrant where cosine is positive. Do it for yourself so you can confirm it. The tan of 3 pi on 2 minus theta. So in this instance here, I would certainly be going straight into sine of 3 pi on 2 minus theta over the cosine of 3 pi on 2 minus theta, like so. So we're using that basic tan identity. Now, sine of 3 pi on 2 minus theta is equal to root 3 on 2. So that's what will be on the top. Oh, sorry, the top will be sine of 3 pi on 2, which is negative a half, sorry. And on the bottom is cosine of 3 pi on 2 minus theta, and that is root 3 on 2. Now, as a bit of a shortcut, if you have a look, if you've got a fraction over a fraction, you can kind of cancel down both denominators if they're the same like that. And we are left with that equaling minus 1 on root 3. Or to rationalise the denominator by multiplying top and bottom by root 3, that would be minus root 3 on 3. And that is basically how you do those kinds of problems.